mobile system, but we are not going to discuss details about operating system in mobile system. Instead of, we can focus on the traditional operating system. We already talked about what is the context switch. So what is the context switch? What is the context switch? You don't know? So you missed the last class? So what is the context switch? We need to switch context. Of what? Context of what? So, context of what? No idea? We are talking about, what's the chapter title? It's a process, right? So unfortunately, we have the limited resource of the CPU processor. Processor at certain time it can process only one process, right? But we have the, as we have seen just before, it's a multitasking, multi-programming. How can we support such a multi-something with a single processor? Anyway, we need to share the CPU time. How can we share? We can slice the time, then assign efficiently and effectively, maximize the utilization. At that time, whenever you change the process, we cannot change it, replace the entire process resource. Instead, we can manage such a process information using PCB, and context switch include such a copy the process state, processor information to the PCB and replace such a resources. So context switch include first stop the current process in case what? For example, interrupt signal from the other devices. For example, there is a process who requests the input and output, then that process that probably move to the wait state, then go back to the ready to be called by the scheduler. Or once the input and output read or write, the operation is done, this controller informed to the operating system CPU. How? At the time, send the interrupt signal. Then CPU will interrupt it, then take care that the request. So that is the current process is a stop. Sometimes voluntarily. Voluntarily means if the current CPU takes a certain amount of CPU time, even though there is no I/O wait, other interrupt, it's voluntarily stop the process and give the chance to another process to be fair with. So that is the first step, and then update the PCB. PCB is the data structure to keep the information about the process instead of handling entire process. Sometimes process is much bigger and keep a lot of the resource. However, the operating system take care only the information about the important information about the process that can be stored at the PCB, process control block. And for example, other operating system function such as a scheduling, CPU scheduler, will take care only the PCB for each process. So copy the OS update the information about the process and the PCB, and then bring that include even the CPU register, contents of the register. It's a storage in the CPU that will be also copied to the PCB. Also PC, what is a PC? It's a program counter. The CPU should know where is the stop, which instruction is the stop, what will be the next the instruction. It's a program counter. So such information is stored. Then CPU scheduler, short-term scheduler will select the process from where? We learned about the 5 states of the process. First, if the process is executed, that will be new process. Okay? Then, if it is ready to be called by the CPU, processor operating system, that is ready state. So ready state is managed by the queue or some other data structure. Also, this is the running. Okay? Sometimes the running process back to the ready state. Also, it can be IO state. IO state means, as I explained, in case there is a request of the input and output, it takes a long time. We want to share such a waiting time with other process. You can move to the IO wait. Okay, then this is terminate, end of the process. So CPU scheduler or the short-term scheduler or dispatcher will select the process from the ready queue. Okay, so CPU scheduler will pick up the ready queue. That process has the PCB and information that were copied from the last state. Then that will be loaded into the CPU and give the information to the scheduler and operating system. That is called context switch. So, question: the more context, the better performance? So you need more context switch in your operating system, right? Agree? Yes?
No.
No. Context switch, as you can see, you need anyway IO, right? To bring back the whole information from the register, okay, and store somewhere in your operating system. It can be memory. Also, sometimes it can be some file structure. It requires I/O operation, and it needs computer resource. Also, you need to bring old PCB to the CPU and register and operating system. It takes a time. A certain amount of time, even your CPU cannot do anything. It's just a waste of your time, even though that is a small amount of time. Okay, so when you have, so best utilization is you can use all CPU time with the one process without waiting or the changing anything. That is 100% CPU utilization. The problem is the other process cannot get the benefit of the CPU resource. That is the reason we'd like to share. Okay, so you need to optimize. However, we need to do such a context switch, change the process. Not very frequently. Every 0.0000 millisecond? No. So you need to optimize the tune your system for such a context switch. So what kind of operation on the process? Process, we can create the process and terminate the process and some other operation. So first, the process creation. How can you create the process? It's your first. See the first one. It's okay. So what is the process creation? How can you create the process? By parents, right? So by parents process or current process. If you have the current process, that current process can create the process. How? What is the by the way process? Process means it's a memory structure that has the instruction. You can do the same thing when you create the process, children process. You can make the space data structure on your memory. That can be done by the system code, system library. When operating system has been developed at the time, the developer already create the function library. Okay, that can create the children process. So first, that is a copy that can share sometimes or give the permission to use their own resource. We will see later. So parent process can create the children processes. Only what? You can create as many processes as possible. Okay. So eventually, when you have the process, it's a kernel process. Sometimes it's called the init process. It can be 0, it can be 1. It depends on operating system. Some of the operating system are assigned the 0 for the kernel process, init process, sometimes 1. It doesn't matter. Then it will create some system process first. Okay? Swap process. Something, the IO process, or something other. So that will be assigned 2, 3, 4, something like eventually. So when you log on your system, operating system, it has interface, user interface. In Unix, it will be shell programming, shell environment, terminal. Okay? In terminal, it has a shell process. When you are using the Windows has the Explorer. Explorer is the kind of the terminal. Yeah. Also, you can use the CMD command line interface. That is your interface that can create another process. For example, if you double click the MS Word, MS Word is a children process of this one. Okay. So what is this? It's a tree structure. So usually the process forms a process tree. Okay. By the way, what is a tree? It's a data structure, right? It's a data structure that you learned in the data structure or Java course. Yes, Java uses the tree structure. Not only Java, but any program language actually implemented such a tree structure. Database use a tree structure, and software engineering even utilize such a tree structure. Then, by the way, what is a tree? Sequence, you can have the sequence can be the structure, one of the structure like the linked structure, but that's different from the tree. It's different way of the link, like this one. It's a queue structure. So you can implement a queue structure using linked list, right? What about the tree? Tree has parent and children relationship. Okay? It has so there exists root node and terminal node or leaf node and internal node. Except leaf node, terminal node, and the root node, internal node has parent and children. Also, but root node has only children node, while the leaf node has only parents node. It has the parent and children relationship. Okay, that is a tree structure. Similar data structure is graph. Here's a graph. So graph is like this one. What is the difference? So what is a graph? Also data structure. Consists of a number of nodes and number of edges. Okay? Edges is the relationship between two nodes. What's the main difference? Which one is more general than other?
Difference, there's parent wall.
No leaf node, no parents node, it's nothing but node, right? So this is the more general. It can represent the relationship between two nodes, okay? So that is the reason this graph node is very popular to represent very complicated data structure, such as social networks. Social network use a graph structure a lot. You can see this is a Facebook user, this is a friendship or the like, and another user. So you can find there is a certain user in the middle of the graph. So this user might be the core, something like that. Or opinion reader. So you can use graph structure nowadays such a way. So that is the tree. Anyway, process tree. Process from the process tree. So each process has process ID. So process ID is the identifier, not process name actually. Process name is one of attribute, okay? Which means in the financial life, nobody recognize me as my name. Instead, social security number, okay? In computer, so using the social, there might be some, even in United States, even though I'm not using the English name, there exists the same name of guy with me. So, but we are using different, the social security number. So in the system, we do not use the name of the file, name of the process, but we use the number. It's a process ID. What about the file? File is file descriptor instead of the file name. File descriptor is kind of the number, okay? So when you create the file, actually the file descriptor is created. Actually, this is a little bit different story, but anyway, in operating system, in computer, everything can be considered as the file, okay? So for example, network connection. What does that mean? When you make the connection, establish the connection to the certain computer, which means in that computer, destination computer, that network server or the certain server create the file descriptor. Okay, then using the file descriptor, you can send a message, you can receive the message, you can do something. Even when you create the file, you can store the data, or you can, when you create some other data structure, it can be considered as a file. That's the so it has that process. Okay. So basically, the parents, the creating process means the parents actually copy, make the clone of itself in the memory, then the load this program instruction to that assigned the memory. It will be the children process that can be implemented in the Unix fork system code, system library, and EXEC system code. For system code, create a new process. New process means it's just copy of the current process. They share actually a lot of information. Just like the parents and the children. Actually, in terms of DNA is not exactly, because there's something mutation or whatever. But in the process, creating process is copy. It's not exactly the same. Depending on the types of process, sometimes you can share all the information. Sometimes you can share the certain part of the information. Sometimes nothing shared. How can you do that? You can execute. EX is the function. Load the separate program. Even though I create the process, even though it's a copy, anyway, the children process can be MS Word. Me, parents process is a shell programming, shell process, but the children can be different. How? During the EXEC, load different program instruction from program in your hard disk drive. Okay? So that is the EXEC. But nowadays, many of the current operating system they provide, and basically it's the same system called fork and EXEC. However, why do we need to use the two different system code? They combine into one. So create process or something process. Well, we fork in process. So this slide shows. So you know it has the text data and set area. So when you fork, it's shared. So actually the same. Allocate only the memory space, and during the EXEC, load the separate code. So this is, then eventually it will create the process tree. Okay, then there is a way you can understand what is a fork, what is an EXEC. This is a pattern, okay? And make the clone and allocate the load the different program instruction, that is the EXEC. Once that is done, okay, the children process send the signal to the parent. During that time, parent process actually waiting for the signal from the children. So like if you have the dance party and the 9 p.m. during your high school, so your parents will wait until you return, right? No? Anyway, so most of the parents will wait until the children is back to home, just like that. It wait until children process is, because it's a tree structure. Tree structure is a very strict data structure. Each process depends on the parent process. If you disconnect this one, it's not tree structure, right? It can be graph, but it's a tree structure, which means if something done, I don't need this one, you need to inform. And parent is waiting up until the children process is ended. So that is the wait signal, and during that time, parent is waiting. Once the parent process got the response, then it will be resumed. Okay. So this mechanism can be described. Yes.
Is there limitation in for the child process
Number of?
number of limitation?
No. So it depends on operating system. But this one shows the single children process, child process, for your understanding of the concept of creating process. But that will be limited by the research, definitely. Okay, then this one is a C program. So I think that if you are studying the system programming, especially Unix system programming, this program is a kind of a hello world. So first the system program, how to create I think that some of you guys already did in your C language. If you already took the C language, so you did this one. So for example, you have the fork. The output of the fork is the process ID. Okay, so output of the process ID. Which process ID? Parent process ID or children process ID? It is children process ID. So if that is a 0, 0 means fail to fork, create a new process. There can be many reasons. There will be many reasons like the limited research or the something wrong. Anyway, at the time fork failed, otherwise, so it will, you can, the minus is, first when you fork, that is a 0, okay, because it's not separated yet, okay. Their program code is the same. So process ID is still 0. It's kind of the pregnant of mom. It's pregnancy. But still, it is able to execute the other command. Because this children process is the same as parent. If you can, your parent process, the current process can execute the something command, even child process can do that. So that this command shows the execrp means it's the function to run the command line interface. The command you can use in the command line interface. So like the ls command. Okay. After exec, it will be the new process ID will be assigned to the children process. Okay, then parent process is waiting until this one is done. When this one is done and go to this one, okay, then child process is completed. You can just copy and paste and compile using the GCC in your Unix or Linux or the macOS. Why don't you test it? This one is the example of the Win32 API. So you can see the different, the system code, like the create a process, but the semantic, in terms of semantic, is the same as the previous one. So after you create you can see such a process list. To list of such a process, you can use ps command in Linux environment. So I upload the PDF file to the Canvas for your voluntary exercise lab at your home. So why don't you can download the VM from the website, the internet, or any the Linux system, or you can install the Ubuntu, whatever. If you can have if you are using the MacBook, you can use the Mac OS for testing. Why don't you practice by yourself to get familiar with Linux and Unix environment? At that time, you can test some of the commands like the ps. So in this case, this is the username who started this process. Most of them are here the root, which means when this system starter, they are started. Root is a super user in the Linux system. Okay. And their process ID is here. In this case, is a scheduler is a 0. Okay. So in this operating system, they decide the scheduler is the first process to create the init, the kernel process. So kernel process is 1, then all of this, the parent process are the init process. You can see the process tree using the command P3. Okay? Like this one, for example, probably this is mine. Right, P3 command here. I am using C#. Okay, parent ID. This one is actually created by SSHD. What is a SSH? Secure shell. Talent is not secure, not encrypted. So nowadays, whenever you log on the remote system, you use SSHD, secure shell. So this is a secure shell server, SSHD. Okay, and this one is also thread, multi-processes. Not only just one, it's many. Okay, then 263 is created by the root. It's a system process. What about the Windows? Windows is the same. Even though you cannot see such a tree structure, when you open the task manager just to show the list of the file, but there is a command you can download from the internet. So somebody implement the application. I think the PS list is one of them. This is a PS list application to see the process list by tree structure. So you can see the same tree structure, process ID and the priority and how much memory they are using and so on. So for example, where's the PS3? PS list is here. It's executed from the command line interface. This command line interface is executed by the Explorer. Explorer is the main process. What about the termination? Termination is among the process state is the last one when the process is ended, end of your program instruction. Then whenever the one process is terminated, end of instruction, you need to inform to your parent process, I'm done. That is terminate. Okay. Sometimes you wanna stop, forcefully, your children process or the current process. It is called abort. Okay. Abort means even though you are in the middle of instruction, you wanna stop the process and get back all the resource. Okay. So that is the abort. So you can see. There's no diagram to see the difference of the abort. Okay. So parent can terminate such a children process forcefully. At that time, you can send the abort signal. That can be, for example, under Unix environment, it's a kill signal. Okay. Then what happens when process is either wait, either terminate or abort. That means all occupied resource will be returned to the operating system. Then can be used for other processes. What if parent is exit? This one would like to exit, which means we would like to terminate. Okay? This process can do that, can inform to the parent process. What about the children process? Mostly it depends on the operating system. However, mostly it can be terminated automatically. Okay? So that is the reason while you are running the program, if you exit your shell or interface or log out, your running process program will be the exit. It's not exit, it's a abort because it's in the middle. Basically, it's the same process, but it's a different shape. The exit means it's a gracefully finished. It's done everything. But abort means in the middle of instruction, it's done. Okay, so it will be terminated forcibly. So that is abort. That is called the cascade termination. Sometimes children process can stop the parent process by sending the signal. But mostly the parent or super user can stop the process. That is the reason sometimes to kill the zombie process that I explained the last time. What is a zombie process? Ghost process. Without parents. Okay? So because there is no the parent process, how can we stop? You need to ask the teacher, a policeman. So like such a thing, so we can ask to the administrator, the root user, to kill such a zombie process. So that is implemented in system called kill or sig kill. In your program, you can use the sig kill and process ID. This open, actually basically it's the same thing. If no parent is waiting, which means I cannot be stopped. But still keep the computer resource, that is called the zombie process. Actually, in fact, whenever you create the process, the point 0.00000000001 second, every process should be zombie process. Right? There is not connected. Slightly, it can be but it does not have. But if you have the zombie process, it's running forever. Mostly, they waste of the resources, so you need to kill it. Also,